Hello, welcome back to Mathematics with Blessing. Here we're going to teach chain rule under differentiation. Now, when I was giving my former videos, I wrote out the different methods of solving differentiation, and chain rule, which is also known as the function of a function, is there. So, what is this all about? Is when there is bracket in a given y given to you, showing that a function is contained in another function. So have y is equal to 4x plus 9 raised to power 6. This is an example of what you're going to use chain rule to solve. So this is not like the normal differentiation, the normal general principles, the normal first derivative that we used to know. This is the one you're going to use, another method called the chain rule. So how do you solve this? To solve this now, let's say, how do you solve it? You see, okay, they say find dy over dx with respect to x. Now you first of all say let u equal to 4x plus 9. This makes our y to be u raised to power 6. So this contains in this function. Alright, let's start. To differentiate this, you say dy with respect to du is equal to 6 minus 1, which is the same thing as 6u raised to power 5. That is dy over du. But you're not yet done. You still have this. You say du with respect to the x. So you differentiate with respect to the x, so u here. So you have, when you differentiate this, you have only 4. So how do you get your dy over dx? To get dy over dx is equal to saying dy over du multiplied by du over dx. Looking at this now, if this cancels this, you only have dy over dx. That's why I put it like this. So dy over du, if the u cancels the u, we still have dy over dx. And right here, we've solved dy over du, which is the same thing as 6u raised to power 5 times du over dx. Here, du over dx is 4. So when you multiply this, you have 24 raised to power 5. Why we know our u as the value of 4x plus 9, so you put it inside, you have 24 bracket 4x plus 9 raised to power 5. So this is the derivative of this. This is the chain in dy over dx. That is the derivative. What if an exponential function is given to you to solve using function of function? What are you going to do? And a good example of exponential function is, for example, if y equal to exponential, let me say 5x raised to power 2 plus 3. There's a good exponential function. How are you going to solve this right now? So if you're given something like this, what are you going to do? Okay, so you say let me make use of u equal to 5x squared plus 3. So if our u is this, so we have that our y is exponential u. So let's differentiate using the chain rule. Now let's differentiate dy with respect to du. If we differentiate this exponential function, it will definitely give you this exponential function. This is the differentiation of this, where there are some standard derivatives that you need to know. I'll give it in one of my videos. So this is one of the standard derivatives of exponential function. So when this such is given to you, what are you going to do? So this is it. So coming to this one, you say du over dx. Let's differentiate with respect to our x. So we have this with times this, 2 times 5x raised to power 2 minus 1. So we have 10x. That is the derivative of du over dx. So to get dy over dx, we have dy over du times du over dx. So from here, we got that dy over du is this times 10 raised to power x. So what do we have? We have 10 raised to power x u. Okay, so what are you going to have? You have your u as this. So you put it inside it, you have 10x exponential bracket 5x squared plus 3. So this is an exponential function that has to do with chain rule.